Everyone, and welcome to a video covering the basic functionality of a series circuit. So in this video, we'll be looking at the basics of how a simple circuit would function. So an electric circuit provides a pathway for an electric current so that it may do the work we want and where we want it. So in this example, we see that there's a fan and we want the fan to work, so we attach it to an electric circuit. And that circuit needs a power source, which in this case is a cell, and the cell provides a voltage, which in turn then generates an electric current that moves through the fan doing work, which for us is cooling us off. So the fan converts electrical energy into kinetic energy. It does this because it uses an electric motor, and the symbol for the motor is seen here. If you want more information on symbols, I have another video that covers that in more detail. So as far as I know, none of us were born with the powers of Marvel's Thor, and we cannot manipulate and or generate our own electric currents at will. But we can use electric circuits to do the work for us. And the way we do this is, first of all, we need a power source, which in the case of simple circuits is usually a cell or a battery. And the way a cell or battery works is it converts chemical energy into electrical energy. And it does this by means of chemical reaction. So inside the cell, there are different chemicals, and when they react chemically with one another, they create different charges. The positive charges are collected here by the positive terminal, and the negative charges collected by the negative terminal. This difference in charge creates electric potential or voltage, and that voltage then can generate an electric current through the conductive wire. And if you put something like an output device, like a light bulb, for example, on that wire or connected to the wire, the electric current can flow through that and then cause work to be done on that device. So that's basically, in a nutshell, how we do it, or how we get it to do work for us. But there's more to it. And for the sake of clarity, I just want to give the difference between conventional current and electron flow so that there's no argument or confusion, right? So firstly, I'm going to talk about conventional current. And conventional current is talking about the flow of positive charges through a circuit, which is from the positive terminal of the cell towards the negative terminal of the cell. So that is the flow of the positive charges. That is the conventional current. But a more accurate way of thinking about the flow of energy in a circuit is actually to think of the electron flow, which is from the negative terminal towards the positive terminal of the cell. And that actually talks about the movement of the electrons themselves. The reason why there's two different directions of when we talk about like flow of energy is because conventional current was established first. So when Benjamin Franklin was looking at electricity, he had to decide how it flows through the circuit. And so he decided that it was the positive charges that move through the circuit, and because they positive charges, they will move from the positive terminal towards the negative terminal. And only much later did we discover the electron. And then we realized, oh wait, it's the electrons that are flowing, and because they have a negative charge, they are moving from the negative terminal of the cell towards the positive terminal of the cell. And that's why we actually have two different directions here. So yeah, it's an interesting story, but yeah, I don't want you to get confused. And if you're in primary school and you were looking at this, you don't have to remember it or for anything particular, but it's good to know anyway. Right, so how electrons or electrical energy does work is that when a circuit is closed, the voltage generated by the power source, which is a battery in this case, allows an electric current to move through the circuit and then do work on the output device, which is a light bulb in this case. When the circuit is open, the current will not flow because basically the voltage is interrupted So the voltage, when the voltage is taken away by a break in the circuit, or if you remove the power source, there can be no flowing current. So the current is generated by the voltage, which is generated by or provided by the power source, which is the cell or battery. And the way that the light bulb works is when the electrons move through the filament, which is this middle section here, the coil in the middle of the light bulb, they actually bump into the atoms more because the wire is not completely straight. And this bumping into the atoms as they move, right, as electrons move through the wire, the filament very fast, I might add, causes a lot of friction. And that friction generates a lot of heat energy. And the heat energy causes the metal to get so hot it begins to glow. And when the metal glows, it actually emits photons. And those photons, the moving photons, are actually what we perceive as light. And that's how a light bulb works. And that's why when you touch a light bulb that has been on, you'll actually notice it's quite hot. And that's because before the light bulb can actually start to emit light, it first has to get very hot. And that's a strain. Well, it's the imperfect functionality of a light bulb that it first has to use a lot of the electrical energy to generate heat before it can even do the light part. Just an interesting side thought. All right, so I hope that was helpful. And never stop learning and stay awesome. Till next time.